The most significant thing to understand in this free response question is the relationship between the graph that's given and the questions that are being asked. Namely, this is a graph of f, not a graph of g. G is defined as the signed area underneath this graph starting at 2. So what does that mean? That means that questions about g prime of x are really questions about f. And questions about g double prime of x are questions about f prime. With that overall insight, let's attack the questions. First, does g have relative minimum, maximum, or neither at 10? Well, again, relative extrema occur in f of x, in the function in question, where that function changes sign. Again, I don't mean to create confusion here. When I write f of x on the right-hand side in blue, these are just the general concepts. I mean any generic function. Okay? So they're asking about relative extrema in g of x, and they're going to occur where g prime of x changes sign. But since g prime of x is f of x, we're asking where does f of x change sign? And as we can see from the diagram, f of x changes sign here, and it changes sign here. Note that it's 0 here, and it's also 0 here, but it's not changing sign. And so students that are inclined to look for where a function is 0 are misled. You have to look for where the functions change sign. So with that, let's write out an answer for A. So again, there's no relative min or max at x equals 10. What is B asking about? B is a similar question. It's about points of inflection. Points of inflection occur where the second derivative of the function in question changes sign. The first derivative of g of x is the graph of f. So the second derivative of g of x is the slope of f. Now let's go on to part C. We have to find the absolute minimum and the absolute maximum. Absolute extrema are found by constructing a table of candidates, and the table has to include the values at both the endpoints as well as at the local extrema. So we construct a table of candidates including endpoints and local extrema. Now let's put in the values. Well, we definitely need to include the endpoints, so -4 is first on our list. Now, we need to include where g prime of x changes sign, or in other words, where f changes sign. Again, that's at -2 and at 6. And finally, we need to include the last endpoint, 12. Now we need to go about finding these values. To do that, we're going to have to calculate the signed area using the graph. But a key point is to recognize that our starting point for all our calculations needs to be at x equals 2. Why? Because that's where g of x equals 0, or more generally, that's the initial condition, if you will, that they've given us. Remember, the fundamental theorem states, as I've written down here, that to find the value of a function at a given point, you have to have a starting point and then the integral, or the signed area, underneath the derivative curve of that function. That's just what we have in f, and so we have to start at the initial condition, which in this case is at x equals 2. So let's do these calculations going forward first, since I think they're a little more easy to understand. First, we're going to go from 2 to 6. Okay? So it's going to be the value at g of 2 plus the signed area from 2 to 6, which is the area of a triangle. 1/2 the base, positive 4, times the height, 4. So that value is 8. Now let's extend that to go on to calculate what it is at 12. So the value at 12 is the value at 6 plus this value from 6 to 10. That's a triangle with area 1/2. The base is 4, but the height is -4. Okay, that takes us out to 10. Now we have to go to 12. 1/2 the base, that's 2, times the height, again, -4. So that value comes out to 8 minus 8, that's 0, and now -4. Final answer for 12 is -4. Now we're going to do calculations that go backwards from our initial point of x equals 2. So remember, our signed area, when we move in this direction, these bases, these moves in this direction are negative. All right. At -2, we have the area of this triangle, which is 1/2 -4 times the height of +4. And that's going to be -8. Moving farther to the left, we have an additional triangle that has area 1/2, a distance of a direction of -2, and a height of -4. That's going to total to -8 plus again the value that we had at g of -2. So that's going to add 4 units to the -8. That gives us -4 again. Now we're in a position to draw our conclusions. Namely, the absolute max is 8 and the absolute min is -8. We'll write that out. In part D, we've pretty much already done the work by doing what we did in part C. We just need to find the intervals where g has a negative value. And we see that, again, g starts out being 0 right here. So all of this move in this direction is negative, down to -8. It starts to increase, comes back up to -4, but it remains negative over this entire interval. So we can say g of x is negative when negative or 0, I guess. Sorry. Negative or 0 when x is anywhere from -4 up to 2. Now, is there an additional area? Well, in fact, there is, because we added 8 positive units to g when we went to 6, but we subtracted those 8 units again when we went to 10. Okay. And so from 10 to 12, we have negative or 0 area. Or 0. That's it. I hope these help clarify the issues.